Alright, a good quarterback can throw a football at 27 meters per second, which is about 60 miles per hour. If we assume that the ball is caught at the same height from which it is thrown and we ignore air resistance, what is the maximum range in meters? And how long is the ball in the air? So, we have a quarterback, represented by the stick figure here, throwing a ball to his fellow team player, represented by this figure over here, at some angle, and this initial velocity is 27 meters per second, and we are asked to find out what is the maximum range that this would happen at. So we have to ask ourselves, we know the formula for range as being velocity squared into sine 2 theta over the acceleration due to gravity. Now, what theta would result in the maximum range? So we know the sine values as being between 0 and 1, with 0 being the least and 1 being the maximum. So what sine 2 theta would lead to 1? We know that sine of 90 degrees is 1. So 2 into what will give us 90? So that theta has to be an angle of 45 degrees in order to give us a sine of 90. So that would be the angle that the quarterback has to throw the ball to give the maximum range. So if we know our velocity initial as 27 meters per second and we know our theta is 45 degrees, that is sine of 2 into 45, which is sine of 90 over 9.8 meters per second square. What we end up with, we know that sine of 90 is equal to 1. So this value is equal to 1. So it's essentially square of 27 meters per second divided by 9.8, which gives us 74 meters. So we know the maximum range is 74 meters. Now we have to find out how long the ball is in the air. Simple. We know that velocity is equal to distance, change in distance over change in time. We know our change in distance is our range, essentially. That's 74 meters. And we don't know our time. That's what we need to find out, how long the ball is in the air. And we know our velocity is 27 meters per second. So our time would essentially be equal to 74 meters divided by 27 meters per second, which gives us approximately 2.7 seconds. So the ball is in the air for 2.7 seconds.